Welcome to Edexemy. This is Higher Secondary Plus 2 second year Mathematics. The chapter we are going to see is Matrices. Are you ready? In this video, we are going to learn how to calculate adjoint of a matrix. What is the definition of adjoint of the matrix? I am not going to explain any definition or any theorem now. We straight away going to solve the problem. We are going to straight away find the adjoint of this matrix. While calculating the adjoint of this matrix, I will explain the definition and the theorems wherever necessary. So let us start to solve this problem. Okay. So let us take this matrix as A. Let A is equals to matrices of this 2, 3, 1, 3, 4, 1 and 3, 7, 2. Let us write like this. Let this matrix is equal to A. Then the question is, we have to find what is the adjoint of A. What is the adjoint of A? We have to find. This is the question. So to find adjoint of A, we have to find the following things. First of all, we have to assign a positive of or negative to the each and every element of this matrix A. Every element in this matrix must be assigned a positive sign or a negative sign. How to calculate that I will explain later. The first thing is sign. The next thing is we have to find the minor for each element. For each element there is a minor and the value of that minor we have to find. Next, we have to find the cofactor matrix. Cofactor matrix means cofactor of each and every element will form a cofactor matrix and a transpose of this cofactor matrix. That's all. If we find all these four things, then we can able to find adjoint of A. So let us start to solve this problem for adjoint of A. Now first, how to assign the value, positive or negative value to these elements. This is the first step we have to do. Now let us take the first number 2. This number 2 will find the cofactor of this 2. We'll find the cofactor of 2. 2 is in the first row and first column. So how to write this element to first row, first column? So you have to write here first row, first column like this. So to find the cofactor, first you have to assign the positive or negative sign here. How to calculate? The formula is minus 1 to the power of, you have to add this row and column. This is 1 plus 1, therefore it is 2. If this is even number, then the value is positive. If this is odd number, the value is negative. Here it is positive, therefore put positive sign here. Then you have to form the determinant, which is called the minor. How to find the minor? You put a determinant symbol like this, and this 2, first row, first column, this 2 element is in the first row and the first column. So you have to leave that first row and first column. This 2 is in first row and it is in first column. Therefore you leave the first row and the first column. Therefore the remaining numbers, what are the remaining numbers? 4, 1, 7, 2, which will form a determinant which is called a minor. So you have to put 4, 1, 7, 2 here. So determinant of 4, 1, 7, 2 is called the minor. So here we will write 4172. So the determinant value of 4172 is the minor of the cofactor 2. Therefore, here plus sign, 4 into 2 is 8, minus 7 into 1 is 7, 8 minus 7 is equal to 1. So the cofactor of 2, first row, first column is 1. Similarly, we have to find each and every element the cofactor. The next number is 3, which lies in the first row, but it is in the second column. Therefore, 1, 2, first row, second column. So, minus 1 to the power of 2 plus 1 is 3, which is odd number. Therefore, it takes the negative value. Negative sign you put and the determinant. 3 is in the first row and it is in the second column. It is in the first row and the second column. You leave that row and column. Therefore, the remaining numbers form the determinants 3, 1, 3, 2. Always the minors will be like this only. So, I have to find the value of this. It takes the minus value, minus of. I will find the value here. It is minus of. You put a bracket here after the minus. Here you have to put 3 into 2 is 6 and 3 into 1 is 3. So therefore 6 minus 3 is equal to 3 minus 3. So the value is minus 3. Cofactor of 3, first row, second column is minus 3. Similarly, we will find the cofactor of this 1. It is in the first row, third column. Okay, first row, third column. Okay, then it is minus 1 of it is in the first row and third column. Therefore, you leave that first row and third column. The remaining numbers will form the determinant, which is the minor of 1, which is in the first row and third column. Okay. Now, minus 1 to the power of 4 it will come. Therefore, automatically we will put plus. Therefore, the remaining numbers are 3, 4, 3, 7. You write here 3, 4, 3, 7, which is equal to 3 7s are 21, 3 4s are 12, minus 12, which will be 9. So, 9 is the cofactor of 1, first row, third column. Now, cofactor of 3, which is in the second row, first column. Second row, first column. Therefore, minus 1 to the power of 3, it will come minus. You can easily write alternatively plus, minus, plus, minus. It will take alternative value. The shortcut method is you can always write plus and the next cofactor will take the value minus. Okay. Now, this 3, second row, first column. We will show it in the diagram. Okay, it is in the second row, and the first column like this. So the remaining numbers are 3, 1, 7, 2. 3, 1, 7, 2, we will write it here. Minus of 6. 3 into 2 is 6. Minus 7 into 1 is 7. 6 minus 7 is equal to minus 1. Minus of minus 1 is plus 1. Therefore, the cofactor of 3, second row, first column is plus 1. So the next number 4, which is in the second row, second column. Like this. It is in the second row, second column. Therefore, the remaining numbers are 2, 1, 3, 2. Therefore, here cofactor of 4, second row, second column. The previous one is negative, therefore this one is positive. Therefore, here 2, 1, 3, 2. 2, 1, 3, 2. You put here 2, 1, 3, 2 like this. So the value is 2 into 2 is 4. 2 into 2 is 4 minus 3, which is equals to 1. So we will find the cofactor of the next number 1, which is in the second row, third column. Which is in the second row, third column. So we will move this to here. Therefore, it is in the second row, third column. Therefore, the cofactor of, here we will write cofactor of 1. Cofactor of 1 is equal to, previous one is positive, therefore this one is negative. We can write the sign alternatively. Okay. So minus of determinant. What are the numbers left here? 2, 3, 3, 7. 2, 3, 3, 7. Okay, we will write here 2, 3, 3, 7. Okay, we will find the value of this. Minus of 7 into 2 is 14 minus 9. 3 into 3 is 9. 14 minus 9. 14 minus 9 is 5, therefore minus 5. Okay, the next number 3, third row, first column. Cofactor of 3 is equal to plus. The previous one is negative, therefore this is positive. Determinant of, what are the numbers left here? What are the numbers left here? We will shift this. We will shift this row to here. In this row, the 3 is okay. We will take that column to the first column. Okay. So it is in the third row, first column. So the remaining numbers are 3, 1, 4, 1. Okay. The numbers are 3, 1, 4, 1. We write here 3, 1, 4, 1. Like this. Okay. Now we calculate the 3 into 1 is 3, 4 into 1 is 4. So therefore 3 minus 4 is minus 1. The value is minus 1. Similarly, we can calculate the cofactor of 7 here, which is in the third row, second column. Previous one is positive, therefore this one is negative. So we will shift this column to here. Okay, it is in the third row, second column. What are the remaining numbers? 2, 1, 3, 1. The remaining numbers are 2, 1, 3, 1. Okay, we will write here in the determinant 2, 1, 3, 1. We will find the value. It's negative of 2 into 1 is 2, 3 into 1 is 3, minus 3. 2 minus 3 is minus 1, minus of minus is plus, therefore plus 1. The value is plus 1. So the final one, cofactor of 2, which is in the third row, third column. Third row, third column. We will shift that column to the last third column like this. Therefore the remaining numbers are 2, 3, 3, 4. We will write here in the determinant 2, 3, 2, 3, 3, 4 like this. Okay, now we will find the value. Previous one is negative, therefore this is positive. 4 into 2 is 8 minus 9, which is minus 1. Now we have found all the cofactor of all these elements. Now we will form the cofactor matrix. Cofactor matrix. Cofactor of each element we have found out just now. Now we will form a matrix using this. Therefore the cofactor matrix of A is, whatever the value you have just found out, you have put it here. You have to put it here. So for each and every value, first value is 1, cofactor of 2, first row, first column is 1. Therefore put 1 here. The next one is minus 3. The cofactor of 3, first row, second column is minus 3. Therefore you put here minus 3. The third one is 9. Similarly, you can fill all these elements. Whatever the value we have calculated, you just fill out. This is minus 5 here. Minus 5. The next one is minus 1. The next one is minus 1, and the next one is plus 1. Okay. Now the last one is minus 1. So we have formed a cofactor matrix. This is called a cofactor matrix. Then you have to now find out the adjoint of A. The final step, adjoint of A, is the cofactor matrix, its transpose. Therefore the definition is, the transpose of a cofactor matrix is called adjoint of A. Now you got the definition. What is adjoint of A? The transpose of a cofactor matrix. Now we will find the transpose. 1 minus 3, 9, 1, 1 minus 5, minus 1, 1, minus 1. Transpose of this matrix. Now what is transpose of a matrix? How to calculate it? You interchange rows and columns. You change rows into columns or columns into rows, then you get the transpose. Now here 1, 1 minus 1, which is in the first column, you write it as a first row. Then minus 3, 1, 1. In the second column you write as second row, and the third column you write it as a third row. That's all, finish. Now you got the adjoint of A. Now what is the definition of adjoint of A? The transpose of a cofactor matrix is called adjoint of A. How to find this cofactor matrix? You have to assign a positive or negative value, then find the minor. If you multiply both these things, you get cofactor of each and every element. Then if you form a matrix, it's called a cofactor matrix. We will move on to the next problem. Now we will solve the third problem. Let A is equals to matrices of 2, 2, 1, minus 2, 1, 2, 1, minus 2, 2. Same as the previous problem. Now we are going to work out directly, not in detail as the previous problem. Now we have to find the adjoint of A. What is adjoint of A? We can put a square bracket like this. Now we will assign the positive or negative value to each and every element first, then put a determinant. We have straight away find the cofactor matrix here and the transpose of it. Now first 2, it is in the first row, first column. If we leave first row and first column, the remaining numbers are 1, 2, minus 2, 2. The determinant of this will be the cofactor of that 2, first row, first column. Okay. Now the first row, second column, the cofactor of 2 it takes the negative value and it is in the first row second column. If you leave it, the remaining numbers are minus 2, 2, 1, 2. 1, 2. Okay. Now the third one, for this one, we will calculate the cofactor. So plus, minus, and this one is plus. It is in the first row third column, you leave it, the remaining numbers are minus 2, 1, 1 minus 2. Similarly, you have to write the value of the other elements. Now, for this minus 2, here plus, then it is comes in the minus, determinant of minus 2 is the second row first column. Second row first column. You leave it, then the remaining numbers are 2, 1 minus 2, 2. 2, 1 minus 2, 2. Okay. The next one will be plus. Determinant of 1, which is in the second row second column. Therefore, you leave it, you get 2, 1, 1, 2. Same as the previous problem, we will find the next number. 2. It takes the negative value. Don't forget to put the plus or minus sign first. Then you find out the minor determinant. Okay. Similarly, we have to put for all these numbers 1. 1 is in the third row first column. So the remaining numbers are 2, 1, 1, 2. So it will take the positive value 2, 1, 1, 2. 2, 1, 1, 2. We will put here 2, 1, 1, 2. Then the next number minus 2 takes the negative. So determinant of this is in the third row second column. Third row second column, 2, 1 minus 2, 2 are the remaining numbers. Therefore 2, 1 minus 2, 2 are the remaining numbers. So determinant value of 2, 1 minus 2, 2. Therefore the final element 2, it is in the third row third column. You leave that third row third column, the remaining numbers are 2, 2, 2, 2, minus 2, 1. Okay, like this. Now, you put the determinant square bracket here for the whole thing. And don't forget to put the transpose T at the top. It is very, very important. Don't forget to put the top. So, cofactor matrix, the transpose of the cofactor matrix will give you the adjoint of A. So, all the steps we will put in this single step. Therefore, we have found out the sign value, minor value and the cofactor value, then the transpose. Everything is here. So, now we will find the value. It is enough if you find the value, we will get the adjoint of A. Therefore, here adjoint of A is equal to now find the value. First one, 2 into 1 is 2, minus of minus, 2 into 2, minus 2 into 2 is minus 4, minus of minus. Therefore, here 2, minus of minus is plus 4. Okay, this is the cofactor of the first element. We will find out the value of the other elements. Okay. Now the second element is negative, minus of, put a bracket here, then here 2 into minus 2 is minus 4, 2 into minus 2 is minus 4, okay, minus of 1 into 2 is 2, minus 2, this is the second number, okay. Now the third one, minus 4 minus 2 is minus 6, minus of minus 6 is plus 6. The value will come. We will write it in the next step. Here the value is Minus 2 into minus 2 is 4. Minus into minus plus, therefore minus 2 into minus 2 is 4. Minus of 1 into 1 is 1. So we will put bracket for each and every element here. Here it is minus of 2 into 2 is 4. 2 into 2 is 4. Minus of minus 2. Minus 2 into 1 is minus 2. Minus of minus is plus. Therefore plus 2. Okay. The next thing is 2 into 2 is 4. Minus of 1 into 1 is 1. 2 into 2 is 4. 1 into 1 is 1. Therefore the next number is minus of, we'll get minus 2 into 2 is minus 4. Minus 2 into 2 is minus 4. And minus of 1 into 2 is 2. Therefore minus 2. Okay. 1 into 2 is 2. Therefore minus 2. And the third row. 2 into 2 is 4. Minus 1 into 1 is 1. And the next one is minus of 2 into 2 is 4. 2 into 2 is 4. Minus of minus will become plus. 2 into 1 is 2 plus 2. The final one is, we'll calculate the value of the final one. Here it is positive. 2 into 1 is 2. 2 into 2 is 4. Minus 4. Minus of minus is plus. Plus 4. Okay. Okay. Now put the square bracket which denotes it's a matrix. It's a cofactor matrix, and put a T here. Don't forget to put the T. You have to find the transpose. The problem is not yet over. Now we will find the value of these elements. Now adjoint of A is equals to 2 plus 4 is 6. Okay, minus 4 minus 2 is minus 6. Minus of minus is plus. Therefore plus 6. 4 minus 1 is 3. Now 4 plus 2 is 6. Minus 6. 4 minus 1 is 3. Minus 4 minus 2 is minus 6. Minus of minus is plus. Therefore plus 6. 4 minus 1 is 3. 4 plus 2 is 6. Minus 6. 4 plus 2 is 6. Therefore we have to find the transpose of this cofactor matrix. Now we have to write the columns into rows. Now 6 minus 6 3 is the first column. We will write it as a row. 6 minus 6 3. Then the second column 6 3 minus 6. 6 3 minus 6. 3 6 6. Okay. So we finally got the adjoint of A. Now the problem is not yet over. What is the problem? We have to find the adjoint of 1 by 3. 1 by 3 into this. We have taken A as this. So 1 by 3 into A. 1 by 3A. We have to find the adjoint of 1 by 3A. So now we will pass on to calculate the 1 by 3A adjoint of 1 by 3A. Here you should remember one thing. It is not 1 by 3 into adjoint of A. There is a difference between 1 by 3 adjoint of A and adjoint of 1 by 3A. So here we have to remember one rule. What is the rule of that matrix? If you find adjoint of a constant multiply by a matrix, then there is a theorem there is a rule. What is that rule? Here, the fourth one, adjoint of lambda. Lambda is a constant. Adjoint of lambda A is equals to, if we take lambda outside, lambda to the power of n minus 1. What is n? Order of the matrix and adjoint of A. Now, we will find what this means. Okay. Adjoint of a constant multiplied by a matrix is equal to that constant you take outside to the power of order minus 1. Now what is the order of this? Now this is 1 by 3 is lambda here and A is the matrix. So we have not supposed to find this 1 by 3 into adjoint of A. Instead we had to find adjoint of 1 by 3A. You must be very, very careful. Therefore, this is not the problem. The actual problem is adjoint of 1 by 3A. So, now, if we take lambda outside, lambda here is 1 by 3. If you take 1 by 3 outside to the power of n minus 1, what is the order of this matrix? In the first year, you have learnt how to find the order. This matrix is of 3 by 3, 3 rows and 3 columns. Therefore, the order is 3. How many rows, how many columns? To find the order, the matrix should be in square matrix. What is a square matrix? If the rows and columns are equal, then it is called a square matrix. Here it is 3 by 3. Therefore, 3 is the order. So, therefore, here n is equal to 3. N is equal to 3 minus 1. This is the formula. Lambda to the power of n minus 1. Then you have to find the adjoint of A. The value of adjoint of A you have to put here. You have to put here. Okay. So now the problem is over. Adjoint of 1 by 3A is equal to 1 by 3 to the power of 3 minus 1 into adjoint of A. So now it is easy to find what is the value here. Now we will put it here. Adjoint of 1 by 3A is equal to 1 by 3 to the power of 2. 2 means square. So square, 1 square and 3 square. You have to square each an element in the inside the bracket. Therefore 1 square is 1, 3 square is 9. 3 square is 3 to the power of 2. 3 square is 9. You put 9 here, and here you have to put all the values here. 6 minus 6, 3. 6 minus 6, 3. 6, 3 minus 6, 3, 6, 6. Okay. Now, if you notice, there is 3 in all these elements. There is a 3 inside of all these elements. You take that 3 outside. How to take a constant outside of a matrix? It should be in each and every element. It should be there. If we take 3 outside, the first element will become 2. 2 into 3 is 6. Then second element will become minus 2. The third element will become 1. And the next element is 2, 1, minus 2. 1, 2, 2. We have taken 3 outside, common from all the elements. So now, the final answer will be, this 3 and 9 will get cancelled. The answer is 1 by 3. So adjoint of 1 by 3 A is equal to, now 1 by 3 matrices of 2 minus 2, 1. 2, 1 minus 2. 1, 2, 2. This is our final answer. Adjoint of 1 by 3 into A. This is how we have to calculate adjoint of 1 by 3A. This is the answer. See you in the next part of this series, Matrices series. Until then, this is AJH signing off. Thank you.